The first law of limits is the sum law. The sum law basically states that the limit of the sum of two functions is the sum of the limits, like these ones. First we have that f of x plus g of x in the same parentheses, it's equal to limits of f of x, x approaching to a, plus limit of g of x, x approaching to a. For example, we first evaluate the limit x plus 2 when x is approaching to 5. By the sum law, we have that this limit is equal to limit of x plus limit of 2 when x is approaching to 5. First, we have to separate the numbers in each limit, and we know how to evaluate the two limits on the right hand side of the last equation using the two special limits we discussed above. That is limit x equal to 5 when x is approaching to 5, and limit x plus 2 when x is approaching to 5 is equal to 7, because we have to substitute here the 5 and then we make the operations. From the sum law, we directly get the difference law. In this case, we have that limit of f of x minus g of x is equal to limit of f of x when x is approaching to a minus limit of g of x when x is approaching to a. In this example, we had that limit of x minus 5 when x is approaching to 7, it's equal to limit of x when x is approaching to 7 minus limit of 5 when x is approaching to 7. In this case, we only have to subtract and substitute the 7 in the x. So we have limit x approaching to 7 is equal to 7 minus 5. This is equal to 2. Constant multiple law. The limit of a constant times a function is the constant times the limit of the function. In this example, we have limit of 3x plus 1 when x is approaching 5, that is equal to 3 limit of x when x is approaching 5 plus limit of 1 when x is approaching 5. So first, we substitute in the first function, and it will be 3 plus 5 plus 1, that this gives us 3 plus 5, 15, plus 1, 16. The limit of a positive integer power of a function is the power of the limit of the function. In this example, for power law, we have limit of x to the 4th minus 1 when x approaches 2. So now we have to factorize, and we will get x squared plus 1 times x plus 1 times x minus 1 when x approaches 2. And now we have to substitute the x in the equation. We have 2 to the square plus 1 times 2 plus 1 times 2 minus 1, and this it's equal to 4 plus 1 times 3 times 1, and our final answer is 15. The limit of a quotient is the quotient of the limits, provided that the limit of the denominator is not 0. In this example, we have that limit of x minus 1 over 2x when x is approaching 2, it will be equal to the limit of x minus 1 when x approaches 2 over limit of 2x when x is approaching 2 according to the quotient law. So it will be equal to 2 minus 1 over 2 times 2, and this will be equal to 1/4. The product law basically states that if you are taking the limit of the product of two functions, then it is equal to the product of the limits of those two functions. The limit of a product is the product of the limits. So we have limit of x times 2 when x is approaching to 5. This will be equal to the limit of x approaching to 5 times limit of 2 x approaching to 5, and this will be equal to 10 because we substitute the 5 in the x and we just make the simple operation. The limit of a positive integer root of a function is the root of the limit of the function. We must remember that if n is an even number, we assume that the limit of f of x is greater than 0. In this example, for the root law, we have that limit of square root of x squared plus 3x minus 2x when x approaches negative 4. It will be equal to limit of square root of x squared plus 3x when x approaches negative 4 minus the limit of 2x when x approaches negative 4. This according to the law that we are talking about. When we separate, we only have to make a simple substitution in the variables, and now we substitute negative 4 inside the x, so we have negative 4 to the square plus 3 times negative 4 minus 2 times negative 4. This will be equal to the square root of 16 minus 12 minus negative 8. This gives us square root of 4 plus 8, and this is equal to 2 plus 8, and our final answer will be 10. Logarithm law. In this law we have that the limit of a logarithm of f of x when x is approaching a is equal to a logarithm of limit of f of x when x approaches to a. In this example we have that the limit of log base 3 f of x when x is approaching 5 is equal to log base 3 limit f of x when x is approaching 5, and then we have to substitute. Here y will be log base 3 to 27. Then we have to make the change of base of logarithm, and we have that 3 to the y is equal to 27. So we have to find the exponent that gives us 27. That will be 3, because 3 to the third will be 27.